Hello and welcome to today's class. For today, we're dealing on the calculus limit of a function. Right? We're discussing about the limit of a function. By definition, what is limit of a function? A limit of a function at any point describes the behavior of the function at that point. I said a limit of a function at any point describes the behavior of a function at that point. Alright, let's start with what we call the mathematical representation of limit. Alright, let's say I have a limit of a function of x to be equal to L such that x tends to A. How do I write such expression in mathematical terms? It's written as limit of a function of x, f of x, to be equal to L as s tends to, we call it tends to or approach to A. This is how to represent a limit of a function by mathematical sense. Alright, when it comes to limit of a function, what are the technique or method of solving problem involving limit of a function? There are about 5 methods or techniques of solving problem involving limit of a function, and they are as follows. Number 1, method. We said method of solving problem involving limit of a function. So number 1, we have what we call the substitution method. Substitution method. So we call it direct substitution method. So anyone is correct. Substitution method. Number 2, we have the H method. H method. Number 3, we have the limit at infinity. Limit at infinity. Number 4, we have recorded the hospital rule method, and finally we have recorded the series expansion method. The series expansion method. These are like the 5 steps of solving problem involving limits of a function. So let's start with number 1 called the substitution method or direct substitution method. Before we start with number 1, which is substitution method, let's try to discuss some application of mathematical concepts. Now listen, what do I mean? I mean that to solve limit function, there are some basic mathematical tricks you have to understand. So we're going to discuss this trick one after the other. So put down some important technique in solving limits. Some important technique in solving limits. Number 1, we have recorded the factorization. Number 2, we have recorded the expansion via binomial theorem. Expansion, right? Via binomial theorem, right? We also have rationalization, and finally we have dividing by the highest variable involved or include. Dividing, let's say, by the highest variable involved, right? So these are the 4 techniques when it comes to solving problem involving limits. If you don't know this one technique, you can't solve a limit of a function, right? So let's discuss this one technique. So after discussing this one technique, we're going to start with what? The substitution method. Let's start with number one technique called factorization. So by mathematical sense, factorization has been discussed in our previous classes. So I'll drop the link on how to solve problem involving factorization method. So for today's sake, I'm going to do some little calculation here for the understanding of precalculus linked to a function. So when we talk of factorization, it is a method under quadratic equation, right? So I said now that I'll drop the link on how to solve problem via factorization method. So let's take an example and let's recall ourselves how to factorize equations. So let's say I have number one example. Let's say I have x squared minus 5x plus 6 is equal to 0, right? I'm going to solve this thing. How do I solve this? The first start is that look for two numbers. When you multiply them together, it will give you 6. When you subtract them or add them, it will give you 5. The two numbers are minus 2 and minus 3. So minus 2 times minus 3 will give me plus 6. Hence, minus 2 plus minus 3, of course, plus and minus what? Minus. Minus 2 minus 3 is what? Minus 5. Hence, I will replace these two values with this. I'll be having x squared. Instead of writing 5x minus 5x, replace this with these two terms here. I'll be having what? Minus 2 attach x to it. Then what? Minus 3 attach x to it. Then a positive 6 equal to 0. At this point here, I will group them into twos. I'll have x squared minus 2x. This one in a group this way. Minus sign we say as minus here. Next up, pick out this out. 3x positive 6 equal to 0. Next up, at this point, look at the term that are common in each bracket. So it's like saying bring out the common term from each bracket. So the common term here obviously is x. I have x. So into x divided x squared, I'm left with x. This is a minus sign, of course, minus. X divided 2x, I'm left with just 2. I have it. Next up, I have a negative sign here. What is common in 3x plus 6? What is common here? 3 is obviously common. So 3 divided by 3x, obviously 3 will cancel out 3. Left with what? X. I'll put a negative sign here. Plus 6 divide minus 3. I'll have minus what there? Minus 2. Right? So plus 6. If I have plus 6 divide minus 3. 3l1, 3l2. Minus plus divided by minus is what? Minus 2. So this minus 2, I have it here. Now listen please. If you want to verify the correctness of this equation, hence, watch out for two things. The answer in the bracket here will be what? Will be the same. Look, x minus 2, x minus 2, I am correct. But in a case whereby you solve this equation and you are having different answer in each bracket, please, you are wrong. You are wrong. So let's have to check the verification of the correctness of this equation. Now, I'll bring out x minus 3. X minus 3. I need this one. Bring out the coefficients of each bracket. The bracket here, what is the coefficient here? X. This x. This bracket, what is the coefficient? Minus 3, which is this, as the term. Next up, this and this are the same. Pick out one. I'll have x minus 2. This one we're looking for. These are the two terms here. These two terms, if you multiply them, it will obviously give you this equation here. Alright, let's do the next step called expansion via binomial theorem, right? Number two. So, number two, expansion expansion via binomial theorem. Alright, I will drop the link on how to solve problem involving binomial theorem. So, first is first, what is binomial theorem by definition? Binomial theorem is the general form of expansion of terms, either adding or subtracting be raised to a particular part or index or degree. When it comes to binomial expansion, for today's class, we're going to be discussing just looking at a concept, right? So, what's the concept? The concept is how to multiply two terms in a bracket. That's all. Now, listen. I'm actually doing all this for us to find limits easy, right? I should have go straight to the point and start solving, but I need to let you guys understand it, right? So that I'm going through this process. So, just let's go along. All right. Expansion via what the binomial theorem. Let's say I have example to recall ourselves under this concept. Example, let's say I have let's say A plus B in this manner all squared. This simply means A plus B is multiplying itself 2 times. Hence, by mathematical expression, this can be written as A plus B all into A plus B. I have this. At this point, now here's the logic, please. Pick out the first term here, multiply by all the term in the second bracket. Next up, pick out the second term, multiply by all the term in the other bracket. I said, pick out the first term in the first bracket, multiply by all the term in the other bracket. Finally, pick out the second term in the first bracket, multiplied by all the term in the other bracket. That's like the technique of this concept. So what are we saying? I said pick out the first term here, A, multiplied by all the term in this bracket into A plus B for this bracket. Next up, pick out the second term, positive B plus B into all the term here, A plus B. I have this. At this point, what I do, I will expand, right? Hence, A times A becomes A squared. A, I have a positive sign, plus A times B becomes AB. I have a positive sign here, plus A times B becomes AB. Positive B times B becomes B squared. At this point, give me a final answer. I will have A squared, obviously, from the concept of indices, or from concept of addition. If I have A plus A, I'll have 2A. But if I have A times A, I'll have A squared. Please observe this thing, please. A plus A is never A squared, please. It's 2A. Why A times A becomes A squared? At this point, AB plus AB because of the 2AB. So I have positive 2AB plus B squared as my answer after expansion. Please take note of this logic. Please take note on how to expand in this format, please. Next up, let's move to the third term called rationalization. When it comes to rationalization, it's a technique under sort, right? So which is applied when you are dividing two sorts, right? So for this concept, we discuss two cases. Case one, let's say I have, for case one, let's say I have a simpler term. What do I mean by simpler term? If I have root 3 over root, let's say 2. In mathematics, it is not proper leaving your denominator answer as a root. to erase the root away, you would apply what the concept of what? Rationalization. So how have we done? I will simply, these two terms here, these two things here, I'll have it root 3 over root 2, multiply that one we want to erect. This one, what about what? Root 2 over root 2. We just said it's not proper to have root as answer of the denominator. Hence, what do you do in that case? You rationalize, which I have done. Use it to multiply numerator and denominator. Of course, from the concept of sort, if I have root a multiplying that same root a, I'll have root a squared. A times a becomes a squared. A root is a root here. Hence, this cancels out this. I am left with a. Now, what do we mean here? We mean that if I have a root of a number, multiplying the root of that same number, my answer there is what? That number. So if I have a root of a number, multiplying that root of that same number, I have the number at the end. So hence, if I multiply this and this, that becomes root 3 times 2 becomes 6, all over root 2 times root 2 becomes, from this concept, becomes what then? Becomes 2 as our final answer. This was case 1. Case 1. Let's discuss the case 2. Case 2, when it comes to solving a problem involving rationalization. Alright, for the case 2, let's say I have root 3 plus 2 all over root 3 minus 2. Now listen, before I move into solving this complex problem under rationalization, let's discuss what we call the conjugate. Right? What is conjugate? Listen, conjugate is quite simple. What is the logic there? The logic is that let's say I have A to be equal to A minus B. Let's say I have A is equal to what? A minus B. Or let me use P and say. Let's say P is equal to A minus B. The conjugate of P becomes what then? P bar is equal to what? A plus B. Now listen. For the conjugate, what changes? The sign changes, that's all. I have A minus B. The conjugate of this becomes what? A plus B. Observe this. P is equal to A minus B. The conjugate becomes what then? P bar is equal to what? A plus B. So just change the sign. The opposite sign is the conjugate of an element. So I have this. So let's proceed to solving this problem. Now listen, for this question here, we just said that it's not proper leaving an answer as what? A root for the denominator. So what do you do? You rationalize. For this one too, if you want to rationalize this concept here, I will take this denominator here. So I'll multiply, listen, your first step is what? Multiply numerator and denominator by the conjugate of the denominator. So this denominator becomes, I have root 3 plus 2 all over root 3 minus 2 multiplied by the conjugate of the denominator. Because what? Root 3 plus 2 over root 3 plus 2. This is the conjugate of this one here. Hence, multiply these two, I'll have root 3 plus 2 all into root 3 plus 2 all over root 3 minus 2 all into root 3 plus 2. I will expand this using what? This concept. The natural concept. You can say it's entry tutorial. So I'll use this to expand this. So the first term here, root 3 is the first term here, everything here into root 3 plus 2. Second term here, plus 2 into all the term here into root 3 plus 2. I have this all over the first term here, root 3 into second term here, root 3 plus 2. the second term here, which is what? Negative 2 into root 3 plus 2. I have this. Now expand numerator. I have that root 3 times root 3 becomes what then? 3. We discussed about that when two sorts of the same of the same stuff are multiplying, the answer, the number that becomes what? The answer 3. So root 3 times root 2, root 3 times positive 2, that becomes plus 2 root 3. Next up, I have a constant sign. 2 times root 3, I have 2 root 3. Plus times plus becomes plus. 2 times 2 becomes 4. All over root 3 times root 3 becomes 3. Positive, I have positive sign. Root 3 times 2, that becomes 2 root 3, not 3 root 2. Don't say 3 comes before 2. Becomes root 3 2. No. Root 3 times 2 becomes 2 root 3. I have this negative sign minus 2. Minus a negative sign minus 2 times root 3 becomes 2 root 3. Minus times 4 becomes minus 2 times 2 becomes 4. Alright, at this point, if I simplify this, 4 plus 3 is 7. I have 7. 2 root 3 plus 2 root 3 becomes what then? Positive 4 root 3 all over. Obviously, positive 2 root 3 minus 2 root 3 will be what? Cancel out. I'm left with 3 minus 1, which is what then? 3 minus 4, which is what? Minus 1. Hence, it's not proper mathematics putting a negative sign down. So, hence, I can even write this as saying minus into 7 plus 4 root 3 over 1 is still saying that minus 7 positive 4 root 3, because this divided by 1 is still this. So this has to solve problem under rationalization. For this concept, we discuss it more better when we are dealing with limits itself. So let's start to take example 1 under limit of a function, and let's start solving problem involving limit of a function.